Okay, today we are going to talk about non-level annuities, which are not geometric nor arithmetic. So when you have non-level annuities, you can have different types. For example, arithmetic, which look like P, then P plus Q, then P plus 2Q, and so forth. Or you can have geometric, where you have payment P, P time 1 plus G, P time 1 plus G square, so forth. And then you can have annuities which are not neither geometric nor arithmetic. So how do we solve that kind of problems? There are no specific formula. This is more like you have to read the problem and you have to come up with your own method or scheme. But so because of that, we don't have any theory. What we do some examples and show you um, how to solve these kind of problems. It's pretty much based on your understanding of problem and use what you already learned. Okay, so in this problem, it says only July 1, Dimas wins a lottery. His price is a 20-year. Okay, so 20-year annuity due with payment of 1,000 each July 1st and payment of 2,000 each January 1st. So you can see right away it's oscillating 1,000, 2,000, 1,000, 2,000. So it's not neither arithmetic nor geometry. If the payments are all left to accumulate in a new account, earning interest at annual effective rate of 5%, what is the accumulated value exactly 20 years after Dimas won the lottery? So let's draw the timeline and see what this means. So here is 0. Annuity due, so right away you start with $1,000, then 0.5, 2,000, 1, 1,000. 0.5 mean basically like if this is beginning of year, yes, I know it's July 1st, but if you think it's just like beginning of year for this particular problem, then the January is like half of that year. So that's why I put 0.5. Then 1.5, 2,000, to 1,000, all the way up to the last payment. This would be 19, which would be 1,000, 19.5, which would be 2,000, and 20. Now, the question is not telling us really when is the last payment, but since it's 20 annuity, we will assume that the last payment would be 19.5. So you get 20,000 and 20 2,000. Okay, so this would be the last payment. And then we want to know the value on after 20 years. So future value at this point. Now, what we can do, since the decimals, we use 0.5, 1.5, 19.5, we can expand it to integers. Okay, so I can say 0, 1. So 0.5 become 1 and 1 become 2. Okay. So basically then 19 become 38, 19.5 become 39, and 20 become 40. Okay, so here 1,000, 2,000, 1,000. So here 1,000. This one is 2,000. Okay, so this is basically 6 months. Okay, so this time period is 6 months. The same in here is 6 months. Okay, so now what we can do, we can think this as two cash streams, or if you want it, yes, so let's think about as two cash streams. So let's think about the 1,000 cash stream. So you have 0, 2, 38, and 40. Okay, so it's 1,000, 1,000, 1,000. And what's the value of cash flow, future value? Okay. So how we do this? We know the number of payments are actually 20. Rate per year is given as effective rate is 5%. Compounding per year is 1. Payment per year is 1. Future value is what we want. Present value is 0. Payment, we are getting it. It's positive 1,000. Okay. So let's use our calculator and solve it. Let me let's use our calculator. So I would enter 24N, 5 for rate. Second, that one is 1, 1. Second, okay. And 0 for percent value, 1,000 for payment, and then compute future value. So I would get 33,065 and 95. Okay, so that's the future value of those cash flows. So next, we need to calculate the future value of 2,000 payment. So if you draw the timeline, it's look like 0, 1 here, then 3 here, then 39 here, and then here 40. Okay. So how many payments are there? So what I can do, I can kind of write here -1. Okay, so right away you can see 39 minus -1, that's 40, and it's in every like the difference is 2, so it's become 20. Okay, so anyway, there are 20 payments. You can check it. Okay, and the rate again same as previous one, 5%. Compounding per year is 1. Payment per year is 1. Future value what we want. Present value is 0. Payments are 2,000. But we need to check where the future value is calculated. Future value is calculated on time 41, not on 40, because the time difference between any 2,000 payment is 2. So you have difference between 2. So 39, 2. So you are calculating future value on 41. Okay. So future value at 41. Okay, not 40, 41. So we had to then discount back to 40 to get the future value on 40 because that's where we need. Okay, so here is the total future value. So future value at t equal 41. So let's use calculator. I'm going to use my calculator, even though you cannot see it. You can use your calculator. Okay, so let me reset the calculator. Second, reset, enter. Oh, by the way, we in the previous one we need to set it to the annuity DU. We didn't do that. So for again, you need to calculate this one, set annuity DU. Okay, the same here. So you have to set your calculator for annuity DU. Let me show my calculator. How we do this. The problem is when I do this, you can't see the you can see that other side. So anyway, let me go back and do the first this calculation again because we need to set it on a DU. So let me reset, second reset, enter. So I need annual due, so second payment, second set. So now I need to begin. I would enter 20 N 5 for IOY, second, yeah, these are 1. Then 0 for present value, 1,000 for payment, and compute future value. Yeah, so it's 34,000, 19.25. Okay, that's the value. Okay. So let's do the same with the other one. So second, you said, and second begin. Okay. So I have again 20 for N, 5 for IOY. This are 1. Then 0 for percent value, 2000 for payment, and compute future value 69,438. It should be double of that previous one. 50. Okay, so because since we enter 2000, everything else is same. So you enter 1000 instead of 1000, you enter 2000. So this should be double of that. So this is the value for the this one. Okay. So future value at time t equal 41 is 69,438.50. Okay. Now we need value at time t equals 0. So future value at t equal 40, you have discount by v. Okay. So v time this value. What's v? V is, this is actual 6 months. Remember, this is actual 6 months, even though it's look like one, difference is one, it's not 1 year, 6 months. Okay. So 6 months is, what's the effective rate for 6 months? That's going to be effective rate for year is 0.5. The effective rate for 6 months is, we can take it. So V is going to be what? It's going to be 1 plus 0.05 to 1/2. Okay. Because this V is effective rate for 6 months. Okay. So you are using V, if I write it here, V equal 1 plus I. Okay. Let me write the J. Okay, 1 plus J. So 1 plus J is actually 1 plus I to the 1/2. I is effective rate for 6 months, 1 year. Okay, this is effective rate for 6 months. Okay, so you use that. So you multiply that number by 1.05 to the 1/2. So let's see what we get. So 69,438.5 times 1.06 to the power 0.5, 1.05 to the 0.5. It should be negative because you are discounting. Yeah, I get 67,000. 67,000. 765.04. So you can add this and 34,000 to get the value on 20. Okay, so this is value on 20, um, on 40. So 40 means basically 20 years. So you add this value and this value. So let me write future value at t equal 40. Total, let me write the total. That would be 34,000, so 19.25 plus 67,065.04. T equal 40 mean actually 20 years. Okay, so you can see that this problem really is not arithmetic progression or geometry progression kind of annuity, but it's non-level annuity. So you have to come up with a scheme or trick or method to solve it. Okay, so here's another problem. At an annuity lasts for 12 years. At the end of each quarter, there is payment. First quarter payment is 200, second is 300, third is 150. fourth is 400. Find the equivalent value of this and just after the last payment using nominal quarterly interest rate of 7.2. So if you draw this 0, 0.25, 200, 0.5, 300. The annuity, it says at the end, so it's annuity immediate. Okay, annuity is immediate. 0.75, it's 150. 0. I mean, not 0.1, that's going to be 400. Okay, so then it's going to repeat again and again and again. So the last year would be what? It's 12 years, so it's 11. It would be 400. 11.25. It would be 200. 11.5. It would be 300. 11.75. It would be 150. And 12, it would be 400. Yeah. Now, what you can do, you can break it to four cash flow sequences. So you can draw the 200 ones. Then here 11.25, 200. And then here is 12 and 12.25. Then the other one is the 300 one. Uh, 1.5. So fourth, you can calculate 11.5, 300, 12, 12.5. Okay. Same goes the other one. Now, as you can calculate the first, you can calculate the future value on this time point, 11.5, 11.25. And then the next one would be 11.75. For example, here 0.75, which is 150, 1.75, 150, 11.75, 150, 12, 12.75. Okay. But you have to be careful. You are really calculating the future value at time t equal 12. Okay. So like the previous one, then you had to compound it to 12. Okay. The last one is okay. The 400 ones. It's just after 1 year. So 400, 11, 400, 12, 400. So this one would be the easier one. But the rest of three, you have to calculate the future value at 11.25 and then bring it to 12, 11.5 and bring it to 12, 11.75 and bring it to 12. Okay. So let me do one exam, the one cash flow, and then you can do the rest. So for this one, we can calculate the n equal how many payment we are going to get. We are going to get 12. And then the rate is 7.4, but that's a quarterly nominal rate. So that means compounding per year is 4. Payment per year is 1. And then the present value is 0. Payment is 200. And the future value. Okay, that's what you want to know. So let's calculate this and then get the answer. So here, let me reset. Okay, it's annuity immediate. Okay, so it's not begin first. So 12, n is 12, and 7.44 rate. Then second, here payment is 1, but compounding is 4. Second quit. Then the 0 for present value. 200 for payment, and then you compute future value. And it's going to be 3,008.32. Okay, so now we have to be careful. So let me full screen. So this is on at what time point? At t equal 11.25. Okay. So then future value at t equal 12. Okay. So what you do? So on t equal 11.25, value is 3008.32. And then here is t equal to 12. So you have to multiply by 1 plus I2. What's the difference? So basically 0.75. But you can see the nominal rate is given as 7.2. So here you have 3 quarters. Okay. So what you can do, so the future value of time t equal to 12. 1 plus I4 divided by 4. What is this? This is effective rate for per quarter, and you have 3. Okay, so I4 is 7.4. I4 divided by 4 is 7.4 divided by 4. And what is this? Effective rate per quarter. And this is nominal rate. Okay. Okay, so you can do this. 1 plus 0.072 divided by 4 to the 3. And let's see what we get. Okay. So this is only for $200. Okay, so this is a future value at time t equal to 12 for 200 cash flow sequence. You need to do the same for 300 and 150. The 400 is easier because it's already at n equal. I mean, it's the last one is at 12 here. So basically for this one, 400 is just n equal 12, I over y equals 7.4. Compounding per year is 4. Payment per year is 1. Present value is 0. Payment is 200. And all you need to do just payment is 400. And all you need to do is get future value. There's no adjustment for this future value. But these two future value, you would get future value on 11.5. Then you have to adjust it to 12. You would get the future value at 11.75 adjusted to 12. Okay, so for 300, you get future value at t equal 11.5. Then adjust it to t equal to 150. You get future value at t equal 11.75. Adjust it to t equal 12. So that's your task. Okay, so we did one for for the 0.25 where we get the future value at 11.25 and we adjust it to t equal 12. We got 3,112. You have to do the all other three and get the answer. Okay, so that's the end of that lesson, and we will meet again for the next topic.